Hello and welcome to the channel. So we've got a Marshall JTM60 here, and we looked at this amp before, and this is a part 2 video of this amp. And what had happened with this amplifier is at some time the power transformer had been changed, and the plate voltage on this transformer is too high. It fits on the amp okay, you know, physically and everything, but there's too much plate voltage. Now that problem had led to the tubes being way over biased. These tubes were idling at 33 watts, and you can see that on the first part. If you've not watched part 1, then give part 1 a watch. And the problem with this amp is this board being on its side here. To work on this board, you've got to take it out. It's a real pain. Now the bias trim pot you can just get to, which is down inside here, and you can just get to that trim pot. And in fact, they've if we look, it'll be difficult for you to see inside, but they've stood the trim pot up on its end so you can get a screwdriver in and go in that way. So I started lowering the bias on this amp, thinking that's high, 33 watts idle, and this amp had been running hot. These amps suffer, the problem these amps suffer is they run too hot because the tubes are mounted on the side, sideways. Oh, most of you have seen these before, you probably know all that anyway. So I started lowering the bias on the trim pot, and the trim pot reached its stop, and the tubes are still biased at 21.5 watts, which is way over. They should be biased at 17.5, although they're not. What I can't understand is how the tubes have survived that long. But you know, the customer that had this amp, and obviously he bought it like it is, he's never gigged it, so you know, this amp's really been running at idle. So when a fixed biased amp, which is biased at 17%, which is 17.5 watts, when you start rocking out on that, you crank it up, turn it loud, that bias, those tubes may well go above 100%, which is 25 watts. And I have seen it where tubes, while ever this signal going through the amp, you know, the tubes have probably reached 125%, but they'll run fine like that. It's probably not good for them, but they'll run like that. And you know, a lot of those problems occur because they haven't got big enough screen resistors on the tubes. But this amp was idling at 33 watts, so I've turned the bias preset down, and now it's idling at 21.5 watts, which is still too high. Now the amp will run idle at that, but again, once somebody starts cranking this up, then they're quickly going to red plate, and they won't last long, as they wouldn't have done before. And I can't ever remember, I probably have worked on a JTM60 before, but it's usually this, like on the 30s, this preamp board gets dry joints, and this amp had gone intermittent, and it's got the usual, you know, take this board out, take all the knobs off, whatever, and resolder all the pots, and usually it cures them. Classic fault with them. But on discovering this problem, I want to try and solve it. Now the easiest way and quickest way of solving this, of course, would be to swap the power transformer and get one with the original specs, assuming you can do that, and that would return it all back to normal. But even with the original specs, you know, they could still well find problems, because these amps just run hot anyway. I don't know how much more plate voltage is on this transformer than the other one, because the other problem is, this is the schematic for it, and there's no voltages on it, hardly any at all, and it's also badly written out. So the bias circuit is here, and I've zoomed in on it big time, and it's upside down. And there's no voltages at all there about the bias. And whether we can alter any of these values that you can see on here, to try and get more bias volts onto the grids of the output tubes. So my aim with this project is to try and find out if I can change some components and get a few more volts out of the bias circuit to cool the tubes down a bit more. And this bias circuit is quite complex. We've got 51 volts here, and that looks like a Zener diode to me, and I can't really see for sure because part of the print's missing off there. You can probably see part of the print's missing. It's very difficult to read. A lot of the values you can't read, and you've kind of got to look in the amp and then write them on the schematic. But of course some of them, they're not easy to see because the board is on its side there. So this could be a bit of a nightmare. Now the other problem with this amp that I came across as well was that, and I did all the readings before, when this amp is switched on and it's cold, it drops 495 volts onto this circuit. These caps are rated at 550 volts, which is a strange value for a can cap, but I think it'd be quite hard to find replacements for those. These caps, however, on the preamp stage, you can see it says 450 volts. So every time this amp gets switched on from cold, these are getting belted with an extra 50 volts, only again for a few seconds, but they're still getting it. Now this amp does have a standby switch on here, which you can, if I just click that way, you can see we've got a standby switch. And you could, someone could argue and say, well, just make sure you use the standby switch, because obviously the tubes are conducting once you switch the standby switch in, once you let the tubes warm up, and so therefore you'll only have the normal plate volts on them when it hits them. Well, you'll actually have less than that because you'll have the actual preamp stage voltages. But when this amp isn't drawing any current when you first switch it on, that voltage, that 495, will be going all the way through this circuit. So these are under spec now. Now that you could argue this amp wants recapping anyway. It's 1996, so you know, we're talking 30 years these caps have been in here. So they've been in here a long time. They're all running fine, but they've been in here a long time. So yeah, we could get another transformer for it. That would be expensive, but we could do with recapping this board really, and just checking it over. You know, the amp's not had this board's not been out of this amp for 30 years from when it was manufactured. So that's another option, which is why I'm looking at this and doing it while I've got this board out. I can recap it and recap all the bias circuit as well. I want to try and find out more about these amps, because they're getting to an age now where, you know, some of these amps soon they're going to want some serious maintenance. You either love these or you hate them. The other thing is with these amps, there's not a lot of mods for them if you look online, which is another thing that, you know, we could start to look at with these amps, is how we could make the overdrive better, because a lot of people don't care for the overdrive on these. And you know, that's probably a fair comment. You know, they certainly don't sound like, you know, most of the more popular Marshalls. Right, so here's another thing with this amp. So I've just took these tubes out, and the 6L6s, and I assumed that this amp had got EL34 tubes in when I did the last video, and tested it, because they were encased in that meshing, and I was just doing some voltage readings, and I never took them out, and I just followed the schematic, and the schematic said they were EL34s. Right, so I've come up with a bit of a plan with this amp. So what I'm going to do, I'm going to go with those 6L6s for the time being, and that gets our bias at least where we want it to be. This amp's got some intermittent faults, so I've decided we're going to go through this amp right through it. We're going to start by taking out the preamp board, and we're going to recap it, and we're going to solder all the tracers on the pots, clean off all the unleaded solder, and we're going to just resolder all those, reflow them. We're going to check everything out on the preamp board, and then we're going to take this main board out altogether. We're going to remove this, and we're going to recap this main board completely. And while we're at it, while we've got it out, I may do some tests using a power supply on this bias circuit, and just to see if we can improve it. So we need to label all these cables here first before we do anything else. We've got a nice pot here. I've already took the knobs off. I'm going to go to town on this thing. So notice there's a patch lead in the send and return, so it looks like there's been problems there as well. So and probably those sockets will need a good clean. We definitely need to get these caps. Have been in a long time now. I've been online, and you can buy these 47 microfarad at 550 volts. There's quite a few. Radio spares have them. DigiKey have them. Getting a bit stuck on the D's there. DigiKey have them. Mauser have them. So we should be able to get a pair of those. I'll probably get them from Radio spares. Should be able to get those. These are no problem, but we need to upgrade them to 500 volts. So if we look, if we turn this around, I've taken off the knobs, and you can see the usual deal with these, where you just have so many nuts on the pots, but you don't have all of them. And that one's loose, so we'll take that one off already. Is that in focus? I think so. Probably get some sockets on those and loosen them off. We've got these here. One of those has come off, and that one has. And the first thing that's holding this is a ground wire. We can see now, just gently, while I get something, because I need to rest something between that and the chassis. Anything will do while we just, because we don't want to be damaging that board on this edge here. And the best, it scratches them. So now then, so we've got a cable that's holding that from coming out, and that cable is here. I think what I'm going to do, I'm going to cut that, and I'm going to remake that and put a little bit more cable on that, so when the next guy comes along, it'll be a mite easier for him to work on it in years to come. Right, now I've made a list of the capacitors, but we'll come back to that in a minute. You can see someone's been in here before. We can see all this flux around these components here. Oops. You can see all the flux around the components there. So someone's been in here before having a go at the age-old problem, and the soldering looks good, to be honest. Just as I say, just not cleaned up after themselves. But although that one looks a bit, yeah. So I think we'll suck all that off and make sure we've got rid of all of that unleaded solder if they've mixed it. They do look pretty good. It's just that one looks a bit iffy. but the rest of them don't look bad. But I'm pretty sure that the other thing that makes me think they've been done before, they're very shiny, and as you can see, all the unleaded tracers have got a bit of a matte finish to them. Right, so I've got this board out now, and I've just tap that. I've labelled all of these, and these wires. I've made a list of those, what they are. So if we now we can look at this board, and you can see that if we go to this end of it, you can see that there's, I don't know if you can see that, but there's been quite a bit of gunge sprayed on that, so we need to clean all that off. Right, so we just look where we are with this then. So preamp board's out. We've labelled these and we just took them off. These wires were soldered into the board, and we've just written down where they go. They simply just go through the designated slots, which is W1, W2, W3, W4, and you can see there I've got those. The main board, I've chose to take the cables off here, off the backboard, and they're all off now. We've took the wires off the output transformer, primary and centre taps here, sorry, plates and centre taps there, so they're off. Now the next thing is to get the tubes out, because they're still in, and just drop those in there, because we're going to turn this over. We don't want to damage none of those, do we? And just get those hooks under there. We'll turn this over. So we'll take the output tubes out, and we'll just pop those over there for a moment. Take the preamp tubes out. Let's just have a look. ECC83, and that's been replaced. Not sure about that one, and yeah, so those can go in our blue box, those preamp tubes. So I think these screws here now, oh, and that one's loose, I think they hold the board in. Let's see if I'm right. Well, that one wasn't holding much in, was it? Oh no, neither was that one. My word. You can see the baking on here. All the years of it being cooked. Surely there's more holding it in than these 4 screws. So we need something to pinch those with, don't we? Let's try these small pliers, shall we? Let's give it a go. Use the pliers for that one. That one's gone. Let's try this. And we'll do the same with this one. Something suddenly got rather loose, so I think we might be on a result. And there we go. So you've just witnessed the main board of a JTM60 being removed. Now it's not totally removed, and I might just try and come back with the camera a bit. In fact, what I might do is change lenses. So there we are. So that now we've got some wires that we need to, so this wire and this wire, which is W116 and W118, and we need to put something underneath that because I don't want that board leading on there. So that's those two, but that still doesn't get us detached from the amplifier completely. Got a fuse here, just need to check the bias. So you can see the bias preset pot there now. And now it's starting to rain. Right, we've got a couple of wires here. 3 wires in fact, which is in fact 4. W103, which is blue from the switch. W103 blue switch. This is a bit boring, this. I'll come back when I've labelled all these. And there we go, and that's out. Now we've lifted that completely out. I'm just having a look, and obviously this board has been out before because they wouldn't have been able to have connected the transformer up at that. Well, they might have done on the edge, I don't know. A bit of a scratch there, and there was a bit of a dodgy solder joint on that secondary. So these 3 wires here, the secondaries, the black one is the center tap. So we can now fully recap this board. So we've got some, and those 3300, probably, are they on the filaments? I don't know, but let's have a look. Yeah, I think they are. Looking at the traces, yes, I think they're on the filaments, those. So I've not got none of those, I can tell you. 3300 at 10 volts. That's definitely not. And we've got 3300 at 10 volts for these two also. And we've got a couple of, so these capacitors here are those non-polarized ones that we saw on that bias circuit. And if we hone into the bias circuit again, which is here, and there we go, they are here, C133 and C132. So they're those capacitors there. Now I've got some smaller capacitors here as well, which we'll also be changing, which are 10 microfarad at 100 volts. So they'll be the smoothing on the bias. 10 at 100, is that 10 at 100? Yeah, and you know, anything 10, 22 up to 47 would be okay in there. It wouldn't be a huge deal. So all told, we've got 2, 4, 6, 8, 10, 12, 14 caps on there to change, and out of all of those I've got probably 3 of them. Maybe I've probably got the 10s, certainly in radials, and then we've got these 2 non-polarized, which are 22 microfarad at 50 volts. Don't think I've got any of those either, but that's good. So now we've got the board out, we can make a list of what we need, and we can get on with recapping this board. Now what we could do as well is to have a look at this bias circuit. Now I don't think I can generate any more voltage out of this bias circuit, because I think this is a Zener diode here. I can't read what that says I think that says ZD101. So that is a Zener diode, and it's the fact that the voltage is marked at 51 volts. So if that's regulating around that voltage, then it doesn't really matter what we do in this circuit. That's going to continually regulate 51 volts. So how would we test this then while it's in circuit? Well, the easiest thing, the easiest way for that is if we go to here, we can feed in 20 volts AC and just see what we get in this circuit. I'm guessing that's about 20 volts. Right, you can see if we look on the back here, you can see that this is all with the heat from the tubes where it's been swaging, and you can see on here we've got loads of swage. In fact, there's been so much heat, it may pay us to take this board out here with all the sockets on and just check that for dry joints, for double divergence. Might be an idea. And then we know that this amp's 100%, so that's something we can look at. So let's just look at this board. Oh, and yes, you can see that the two sockets have been resoldered, and you can see that they've left all the, if we just go in a bit more, you can see that all the flux is still on there, but that's no big deal. Right, so you can see on this board it looks like there's something been sprayed all over it, so we've just got to clean all of that off. It's a bit of a mess. Now I've cleaned these pots where they've been soldered, cleaned the flux off, and most of those the guys made a really good job of soldering them. It's just, I don't know, just these look a bit dull, like they've still got the original unleaded, and that one does, and then the other two look okay, so I might just address those two there, and I think we'll be okay with that. So I'm just going to clean all this off with some alcohol, and then we've just got a few capacitors to change. I've got some capacitors to order for this amp as well. Right, so we've finished this board, and you see there it's fully recapped and all soldered and clean. Obviously we've got these because the wires that have got to go in from the when we put the amp back together. So that's that out of the way and done. And now I've got to focus on this power amp section here, and we've got some work to do on this board. These are in a bit of a state, and you can see a few other bits and bobs, and obviously we've got to recap this amp. And I've got most of the capacitors, well, all the capacitors for it, and these you can see here are the capacitors replacements, these 550 volts for these two that we've got here. For these two, got a couple of those, and they came from Farnell's, so yep, they'll fit in there. And we've got some other goodies to go in there, so yeah, quite a bit of stuff. So that's the next job, is to start on this, get this recapped, and then we can get this amp put back together. But we may just have a look at that bias circuit as well. Right, I've got this board all recapped now and cleaned up, sorted out. It's ready to go back in the amp. But what I thought we'd do is we'd experiment with this bias circuit and just see if we can get any more negative volts out of this circuit. Now I don't think we can, and the reason I think that is that this diode here is regulating this Zener diode, and they've got 51 volts down there on that. Here I've got 20 volts going in on, and I'll show you where that's coming in. That's coming in on here, W W7 and W9 there, so I'm feeding 20 volts from the variac into there, or that's what I was expecting to be feeding in based on what I've read on parts of the schematic. But I'm going to feed a voltage into there. We're going to start at around 20 volts. Now I've got the meters there, as you can see. I see my gloves. As you can see, the meters there. The meter on the right is measuring DC. The meter on the left is measuring the AC. So if I start to bring that up, now remember on this amp, the maximum negative volts we could get on that preset when we was running the amp was 48 volts. So you can see as I start to bring that up now, and you can see we've got 24 volts going in there. Now I know that that voltage as well is not going to be more than 50 volts, and the reason I know that is these caps are only rated for 50 volts, and if we look at these caps coming in, oh sorry, we're going a bit of, coming in here, why is that suddenly? So if we look at these caps here, C133 and C132, they are 50 volts working, and you can see they're coming straight in on the AC. There's the diodes, that's why they are non-polar caps. Now you can see as we start to go up, if we look now we're getting up to the volts that we had, the negative, into the negative 40s. Now look what's starting to happen. You can see me pushing up the AC volts, and now I've reached the level of the caps, but we're still at 47.7 there, so which is roughly what we had, about negative 48 volts. And you can see now I've gone past the caps and it's barely starting to move at all, negative 48. So if we come back, and you can see it's staying at negative 48, and I'm still bringing this down. That's because that diode, Zener diode, is regulating the voltage, and you can see now I'm bringing this down. You see it beginning to drop slowly, but look how much voltage is dropping off the AC, and now we're down to we've dropped 10 volts virtually there off the AC, 9 volts, and but we've only dropped 1.5 volts off the DC. And as we start to bring it down, you can see that's coming down there. So if we get this up to negative 48, we need to be careful how we do this, and just let it climb, because we don't want to go over those caps. So those caps must be working right on the edge, because if we're getting negative 48, we're already on 48 volts on the going into the caps there. So yeah, negative 48 volts there, and we've gone over on the caps. So if we just go back, that's the rain on the roof, sorry if you could hear that noise. I can't do anything about the weather. So yeah, negative 49.7 there, and I've still got 48 on them, so keep bringing it down. And now negative 47. And so I'm guessing we must have had AC going into this bias circuit about 46 volts, something like that. Now if I turn the bias preset, I can adjust it downwards. That's obviously going to make the tubes hotter, and you can see that goes right down to nothing. And then we go up. So that's the maximum we're going to get out of this bias circuit because of that diode regulating it. Right, so we've got this board out, and yeah, we're just having a look. So I've got some cracks on the send and return sockets, and that would make sense because there was in fact there was a jumper in there, So that's probably why. So we'll give these sockets, we'll reflow them, and this socket here, looks like someone's done these on the end here. They've already been done. So yes, we'll give that a bit of a swage with this soldering iron, and all should be good. Right, that soldered those. And actually, in fact, there was cracks on these outputs, internal and extension on the speaker sockets. The series loop, but the parallel loop was really bad. They were really badly cracked joints on there. So that sorted that out, and we'll clean that up now, get all the flux off it, and we'll put it back in. We'll give it a bit of a wash on the top as well, because if we look, it's not very clean. So we'll sort that out as well, give it a bit of a bathing, clean off the dust and mess, and then we'll put it back in, and we'll start building this amp back up, and hopefully it should be all good. Right, this is not going to be an easy one to put back together. So we've got the back board in, that's all in now. So I've got this board now, I've got the plastic insert in, and the board's in there. So we've got some screws to put in there. We have to put this board in first, because we've got to sew the wires into this one, and then it goes down and up and into the holes on the front there. And then we've got to put all these wires back. Oh dear, fun and games. So the first thing we need to do is get the screws into that board in, right, well, they're tube sockets, but that's what holds the board in. Just use this because I'm not putting too much pressure on anything. Then you can tighten up with a bigger screwdriver after. You can't really see what I'm doing there, can you? So these are the screws that need to go in there. And that's not got hold of anything, and neither is that. So what's going on there? Well, they've come through. There's nothing missing off those, is there? I've got nothing in here. Let's try the others. They're not binding either. Well, that one is, but the other three aren't. And then we've got some screws to go in here. Well, as we say, we've got a little bolt to go in there. And that goes in here. So you can see there's a bolt there to go in. We've got to try and line that up. It doesn't seem to want to line up very well. Yes, it's not the greatest design. Never understand a company that absolutely perfected the way amps were put together, and then suddenly they start building amps this way. Just lunacy. And it didn't last very long before they went back to the proper way of putting these things together. You just have to persevere. There we go. But these, yeah, only, and that one's not brilliant either, so not a great idea for those. So that's in. As to a fashion, not sure what we're going to do about those yet, but we've got it located. We can come back to those screws after. So I think we can get this board in now. With a bit of luck, we should be able to get this board in. Says he laughingly. Maybe struggling. Something's just. Actually, I just want to sweep out that. There's a solder blob there I've just spotted. Let's get that out. There we go. But yes, we're there. That's good. So just moving that wire, that's allowed us to get that in now. But we've still got to, I'm not going to fasten it in yet because we've still got this mystery blue wire here. I'm not sure where that goes. And of course we've got the green wire we can solder on. I am a plank. I've just realised it goes on the transformer there. Idiot. Oh dear. Yeah, so we good. Looks like we're good to go with this then, because as I say, this green wire, we're not sure where that went, and it was soldered on there, so we'll just solder it back on there. I don't know whether that's a factory thing or what, to be honest. I've no idea. So we've just got that to put on. We'll solder that onto there. I'm not going to film all of that. And then we'll clean this up. I'll clean this up and then I'll come back. We'll start getting the bolts in here. And then we can start putting some of the plugs in. And hopefully, we might be somewhere near with it. Right, I've got all those wires soldered on there. So we're going to start replacing some of these now. And I'm going to leave the labels on for the next guy. That's one. That's C12 in. So let's see what else we've got. We've got lots of these. So we've got C10 here. And that is C10. And there we go, C10. Is that C11? It is C11. Yep, C11 is on. And then we've got another one here. Unravel these. C9. What's that one there? Just try and support the board when you're pushing these in as well. It gets difficult because you can't really see what you're doing either once you put your hands in there. So I don't suppose you can see a deal, because I can't see a deal. But it's gone in. And C8. C8. C7 and C8. So is that C7 hiding there? No, that's C204, so that must go on that board. There's not much point filming this. I'll get them in and then we'll have a look at the ones on the back. Right, we seem to have all the ones in the front and can't see any spare sockets, so we must be there. We'll just keep going till we till we run out of plugs and wires. These 3 here are for the output transformer, the primaries on the output transformer. So let's thread these through here, like so, so they're well away from all of those, and then they go under there, like so, and white is there, red is there. Is that brown or red? Do you know? Looking at that now, I think that's red. It's a bit smudged, that is. Written on there, I didn't write that, but I think that's right. White, brown and red. But of course we can check back on the video to make sure, or I can just test it all out. It's quicker to look back on the video though sometimes, but we can, it's not rocket science really. In fact, that is correct, because that is centre tap, the brown wire there, and the other 2 will go, yeah, they're near the tube socket, they're on the tube sockets. I can see that they're connected to the pins, so yeah, that is correct. Sometimes you can see on these boards and sometimes you can't. That was an easy one. So we need 207, and that's that one there. That one's in, and then we've got 205, that's that one there, but we've got 204 at the back of there, so we need to find that one first. Who are you growling at? It better not be the postman, because he brings all the parts. 205, what's this tucked down here? 204, that's good. So he goes on there, we can get him in. There we go, that's 205, yes. 209, that's pretty elementary, because it's there. And 202 should be that one. Is that everything? Have I connected it all up? Dear oh dear. All fun and games. We've still got a few things to go over though. Blue switch we've done, blue, yeah, white, so they're all done. So I think everything's on there, which means we're ready to put some power to this. Oh no, fail, epic fail. C201, did you spot that wasn't occupied? That's a slap on the wrist. Right, so I've got this now on the test bench, and you can see I've got 15 volts there, and when I switch on, that's what will be going into the amp. So we're just going to use a low voltage just to test this amp. Let's have a look around. I've got a meter above, which should be giving me some voltage, and that's giving me 33 volts, and I've got 20 going, 15 going in, so I would say that's about bang on. Drawing 60 milliamps. I've got no tubes in at all, no preamp tubes in. We just want to check just to see that we've got voltage. So I've got 33 going in there. Yep, that's okay. Yeah. So if we just go up there, you can see on the shelf there, that's the voltage going from the secondaries of the power transformer. Obviously that's been rectified. 33 there, We'll just try down here. Can just get on there. Yep, 33 there. .33 there, so that's good. So yeah, that's all looking pretty good. Now I just need to check the bias voltage. Might have to go into the tube socket on the other side for that. Right, we're ready to fire this up. We've got a speaker plugged into it. We've got this signal generator going in, and we've got meter here measuring the HT coming in. We've got a 40-watt bulb in it, and we've got a meter above there. If I just go up, you can just see that meter there. That one is measuring the bias voltage. Got 139, 140 volts going in. So we're on a 40-watt bulb. Right, let's just go up a bit more on the bulb situation. We'll go for a 60-watt now, just go up a shade. And there we go. We're running. Got negative 31, but again, we've only got 154 volts going into it. Let's check the channel switching. Sure what's going on there. Yeah, maybe we don't have enough voltage. Push channel. It's looking good. Right, let's go to 100 watts. Drawing 200 milliamps. Just pull this out a minute. Now, negative 37. Now the channel switching is working. It's got 342 volts now going on. 343, negative 37, 179 volts going in on here, and we're drawing 210 milliamps. So all's looking good. Right, so I've been having to think about this bias. A couple of 3 days have gone by since I last looked at this, and I've decided I'm going to change that Zener diode, that 51 volt Zener diode, and I've ordered these, and these are 68 volt Zener diodes. I've also decided that because obviously we've had the board out of this once already, but I'm going to treat this as a mod. So what I'm going to do, obviously I've had the board out, so I know pretty much what's what with this amp, but I'm going to approach this from a mod point of view. So assuming that that we're successful with this and we get more voltage on the bias, and obviously these amps are suffering from running hot, and the more it does look like from the evidence that we've got just from working on this, even though it's got a different transformer on, that these amps are somehow over biased. I don't know whether that's the case, because I can't, obviously this one wasn't original when I got it, so I've got no readings on one with an original transformer. But I'm going to treat this as a mod. So what I'm going to try and do, I'm going to try and loosen this board off and slide it out this way so we can get to that Zener diode. I'm going to turn the amp round, completely round, so we'll be pushing it out that way. And I'm going to see if we can get enough space to get this diode in. And if it works, then it'll be a suitable bias mod for these amps, which then people can watch the video, and if they've got one, they can do it for themselves rather than having to take the board out. We may have to still take the board out, I don't know, but I'm going to try. So what I'm going to do is take the screws out so the board's loose, and we'll slide this way, which, as I say, we're turning it around, so it'll be sliding the other way. And then we're going to start, for instance, we might have to take these off to get the board out. We probably will. So we'll document everything we take off, and that can then be all part of doing this mod. And then hopefully we can get to that diode, which is right at the bottom there. So it's not going to be easy. We may even be able to lift the board up a little bit when we've moved it this way. So we're going to, as Arkwright used to say, we're going to jiggle it a bit and see where we get with it. So this diode is BZX79C68. So I bought 10 of those. And we're going to pop one of those in it, and then we're going to see if we can just get that bias volt. So, and yes, I've got these tubes in a good window, because the ones that the second set I put in, because they're low current drawing, but the original tubes are miles out. So just for curiosity's sake, because there's not much documented on these amps, people just, everybody you hear talking about them just say, oh, they run really hot and we put fans on them. But there's more to it than that. You know, you shouldn't have to be putting fans on amps. And I know the tubes are mounted on the sides, but even so, I mean, there's a vent here that goes straight up and through the top of the amp. Right, so if we go in, see what we've done here. So we've got 2 screws in each tube socket. So we take those out, and to get to those, you obviously you go to where the tubes are mounted, and then there's a fix in here, and obviously the screw is on the same side as where the tubes are mounted, where the tube sockets are mounted. Now then, you've got this, if you remember, we had like a black plastic holder that the tube slid into, and then it had got some snap throughs onto the chassis, just some plastic snap-ins. So I popped all of those out, and then to get the last one out, which is over this tube here, you've got to push it up with your, pop it out, push it up with your finger, and then what you do is push on this tube socket till it clears the chassis, and then you can just then get the board out. And you can see now we've got the board loose. And I've got to turn it round, because obviously I've turned it that way because we needed to get those screws out, and you can see that thing has fallen out on the floor, so we'll have to slide that back in. So this is the retainer, and you can see the snap-ins there. That slides, the board slides in there, and then these pop through, and you just pop them out. So we've got this board here now, and we're looking to slide it that way on. So let's just have a look what we need to take off, and we can do this. So some of these need to come off here. Now obviously for me, I've already labeled those, so that's pretty easy. And how high can we lift the board as well? So not very high at the minute. So I really don't know how far we're going to get with this. We might have to take the board out, but I'm going to try just to see if we can do it without taking the board out. I mean, I could just about get in there now, to be honest. It's not easy, but I could get it. Right, so I'm going to unsolder these 2 wires. I've took some of these off, so if you'd have to label them up. Obviously I'd already labelled them. So and we're just going to see how high we can actually lift this board when I've got those out. we'll probably get that up a little bit more. I might just be able to get in there to change that. There we go. I think we can just about get it at that. So I've made a list of what I've removed. We've removed 4 wires from here, just a jump clip here, sorry, a plug here, another plug, few plugs there, and that's about it really. And I think we can just about get into to remove it now. So it's between the two 10 microfarad capacitors. So I'm just going to unsolder that, and so I've just got the camera at a funny angle because I'm having to stand this side of it. So I'm just going to solder that out and get the new one in. Right, so got it all back together, got that diode in, monitoring the bias. We've got negative 48, but I've only got 213 volts going into it because it's got it pinned down on the bulbs. So and it's on standby as well at the minute. Negative 52. Remember we had negative 47 before, didn't we? Just short of 48. We've got negative 52. So let's just flick the current limiter off. Negative 54 we've managed to get. So we have gained 6 volts, a good 6 volts or more. So that's not bad. Now I've got the original tubes back in it now as well. So 54.5, look. So that's not bad. That's just the main voltage, the wall voltage fluctuating. So around negative 55 now. That should be enough, hopefully, to bias these tubes. But we're now going to find out, because what we're going to do now is switch on and see. Not quite sure. Well, we've got. There we go. I've got signal. If the amp's running okay. Yeah. So what we need to do now is we'll just let these tubes warm up a minute and see where we are with the bias with these tubes. May still be over, but it's certainly a lot better. So is that mod worth doing? Yes, if your tubes are running hot and you've run out of bias, you can get a little bit more. It's certainly improved it. We've not got the 68 volts that we wanted from the diode, but we've certainly got, and the simple reason is there's just not enough voltage going in on the AC on the bias circuit, so we've just used it all up. But there was some left, and there we go, we've made the best of it. So let's just check the bias on one side now. So we've got 2.84 on red. So 2.84 divided by, what was it? Can't remember now. 76.6. They were both about the same. Divided by 76.6 equals a nice healthy 37 milliamps. Before that was, we got 53 and 58. Can't remember. I didn't write red down on the original tubes, or it was red or white. I did on the second set I put in. But anyway, so now we need some plate volts, don't we? So let's measure the plate volts. Whoops. So these tubes that are in here are a very high drawing current set of tubes. Or should I say the drawing? 479 volts for the plates. 17.7 we've got those down to now. 17.7, or one of them is. So that's pretty impressive, although the other set of tubes we could get down a lot more than that. Still smell pretty hot though. I wonder if the other ones, one of those tubes is not very clever. So let's try the other side then. Let's try white. 2.9 on that one. We'll go on the other again. I see that one's gone up to 3 volts now. Red. So those are a ferocious set of tubes, aren't they? Ferocious set. But now we could probably put some EL34s in here if we found some that weren't too big on current hogging. Those tubes are definitely big on current hogging. So see, there's a couple of things going on here. There's not enough. We didn't have enough on the bias there, but we've also got this vicious set of tubes in as well. So I think we need to lose this set of tubes for this amp, and we'll put the other set back in. But now we should be able to bias those quite conservatively. I don't think I've got a set of EL34s to go in this. In fact, I haven't. Short on those tubes. Right, I'll let these cool down, and then we'll put this other set in, see where we are with the bias there. Right, got the next set of tubes in there, and got those cooking. Those are warming up. Well, those two are drawing 460 milliamps off the wall, with that's everything combined. So yeah, but let's see, 1.7 on those. Look how low those are. See, they don't draw nearly as much current, yet when I test those on the current limiter, they test better than the tubes that came out of it. 1.7 and 2. So 2 on white. So we'll go for that. 2 divided by 76.8, and they're only drawing 26 milliamps now. So now this amp, there's some scope on that bias pot now. It's not going to be maxed out anymore. 26 milliamps. That's all there. That's running that tube. 26 milliamps. So that bias mod was worth doing. They were biased at 17 watts before, these tubes. So let's see what they're biased at now, and I'll tell you what the current was because it's in my notebook. So the current was 34.8 milliamps. And now it's 26. So we've dropped almost 9 milliamps off those tubes by doing that. 9 milliamps. So the plate volts is 491. That's gone way up, and that's gone way up simply because the bias is so low now. 12.7 watts. So there we go. So those tubes are perfect for this amp, and now we've got those in a right nice window. A window really where you could have some EL34s back in this now. So this amp is just going to run so much cooler. So remember, when we tested this amp in part 1, those tubes were running idle at 33 watts. 33 watts. Right, we've got this Marshall ready to go. Reverb's not bad on it at all. Not too bad. Let's try the overdrive channel. And this thing's really cool now. I had it on for about an hour last night, just left it running idle, and it got slightly warm, but yeah, rusty, especially in the morning. Finishing off with the aeolian mode. Sound too bad. Not bad at all. So yeah, there we go. So yeah, running lovely and cool now. You can bias the tubes up properly. Now, as I said, that may be just because this amp's had the transformer changed, and maybe that's, you know, just a little bit too much plate voltage, I don't know. But it must have had a fairly high plate voltage before. If anyone's got one of these JTM60s and knows what the plate volts is on, please let me know in the comments. I'd be interested to know what the plate volts was originally on the original transformer. But yeah, if you've got one of these and it's running hot, then you can tweak the bias. Just change the Zener diode in the bias. I put a 68 volt one in. You could put a 62 in. You'll get another 6.5 volts, as you've seen in the video. And yeah, she's good to go. So that'll do it for this one. So thanks for watching. You all take care, and I'll see you all in the next one. Bye for now.